formula for defining volume in a sphere? Oh, 4 over 3 pi r cubed.
No, use
Or over 3 pi r cubed.
Right. Let's have a look at the answers starting with number 2. Wong, read out number 2, please.
Estimate what is the pressure on the hull of an aeroplane flying at roughly 10,000 feet.
Okay. So, here is the plane. Here's air. And here's the plane flying here at 10,000 feet. And what did I say a foot was?
3 feet at 1 meter.
3 feet is 1 meter. So this here is 10,000 divided by 3. That's how many meters it is. But this is not the h we care about. What do we care about? It's this one, which would equal 10,000 minus 10,000 over 3. Yes, which is 6667. So the pressure is rho g h, which is about 7 kilopascals. Compare that, no, sorry, not 7, 70 kilos pascal. Compare that to what it is on ground level. What is it on ground level? 101.35. So it's about 0.7 atmospheres, roughly. So it means when you're in the plane is at a pressure of 0.7 of an atmosphere, a lower pressure than what you would be at on ground level. So this is why when the doors open mid-flight, people fly out.
What formula did you use? Rho over GH. What did you get this 66?
That's the H. You have what? Oh, I did this in my head. So it's at 78, I believe you.
10,000 divided by 3. Yeah. Then 3,300. Then 10,000 minus that.
Number 3, Yusuf, what is it?
Explain why the ideal gas law doesn't work.
Tell me, Yusuf. Did you figure it out?
Yeah, because there's no attraction between. There is attraction between liquid particles.
Yeah, there is. Yeah.
Gravity.
Yeah. The two reasons is this density is not small, and the force between the particles is not 0, as you said. So there's 2 reasons it fails the ideal gas law assumptions. 2 assumptions it fails. Number 4. 1. No, I want you to read it. So you can't be wrong about reading.
A building is 100 meters tall and has a base of 10 meters by 10 meters. The density of air to be about 1 kilogram per meter cubed. What is the difference in air pressure?
Right, so the difference in the pressure between
the graph.
Yes, I figured that part. So we'll call this one P1 and P2. Which is bigger?
P2.
So the difference is P2 minus P1, which is rho G H2 minus rho G H1, which is rho G H2 minus H1. And what's the difference in the heights? And remember, we're measuring from the sky, but that doesn't really matter. What's the difference in the heights?
100 meters.
Yeah, so this is 100 rho g. Rho we said is about 1, so it's about 981 pascals. Yeah, so actually it's about 1 kilopascal. And you could easily measure that with a barometer measures pressure. Now you might be thinking, wait a second, hang on. If a voltmeter measures volts, an ammeter measures amps, an ohm meter measures ohms, then why is it not called a pascal meter? Why is it called a barometer instead of a pascalometer? Any ideas?
Because it's easier to pronounce.
No. Barometer is the old unit for pressure. Pressure was originally measured in a unit called bars. So this is why it's called a barometer. Yeah. Is there any other things like that? Yeah, no, that's it. Okay, is that okay for number 4? Why what? H1 is 100? Well, this is H2, and this is H1, the sky. Because remember, the H in the formula is how far down you're in the gas.
I even don't know the Q1 and Q2.
The different pressures at the different heights. What's confusing you?
Why did you minus? Right?
What is X1?
The height from the sky,
Yeah, but you don't know the.
but it doesn't matter because I don't need to know them. I just need to know the difference. I only need to know the difference.
How is it different?
100.
Why?
Because I said it's 100 in the question. You told me the building was 100 meters tall. Yeah. Yeah. Yeah.
Can't say anything about the difference between S1 and S2.
What?
It takes from round
Look,
round to top.
here's the building, right? Do you know this distance?
No?
No. Do you know this distance?
No?
No. Do you know this distance?
Yeah.
If this is H2 and this is H1, how big is this? H2 minus H1. As long as these start at the same point.
But you can find out actually.
You can, but don't. That's how you did it, I know.
Can we use the pressure at H2 being the 101.3.0?
You could use that, yeah. So you notice how the 10 by 10 was not important information. Yeah. Okay. Omar, give me the information on number 5, please.
What is the kinetic energy of the air in 30 centimeters, 1 second?
Right, so energy is 3 over 2 PV, which is 3 over 2 P times 4 over 3 pi r cubed. What is the pressure in a balloon?
Air pressure.
0.15.
Yeah.
Not 0.15.
It's a...
No.
Oh, did I say it was radius or diameter?
You just said it's 30 centimeters wide.
Thank you. What is the pressure in a balloon? A balloon. It's an atmosphere. Yeah, it's the same as air pressure, because if it was bigger, then the balloon would expand, yes. And if it was less, no, sorry. If it's bigger, yeah, it would expand. And if it was less, it would contract, yeah. So to keep the shape the same, it must be the same as the pressure in the room, which is an atmosphere. So this is 2 times 101.35 times 10 to the 3 times pi times 0.15 cubed What is that, please?
2.1
Yusuf?
times 10 to the power of 9.
Is it? That's huge. But I mean, it could be. No, that looks too big. Oh no, actually maybe. Yeah, it could be that. Yeah, 2.1 times 10 to the 9 joules. .1 gigajoules? Did you get this answer?
1.9.
What's that? 2.
1.9.
Oh. Oh yeah, sorry. Yeah, sorry. 2149 joules. This is what you got? So that's 2.15 kilojoules. Okay, can we, yeah?
So you said that the
The pressure is 1 atmosphere because there's my balloon and there's me.
It didn't say balloon is
What did I say it was? Huh?
It didn't have, it might be on the mountain and balloon.
Could be, but we picture it's not. So if the pressure here was more than 1 atmosphere, but this is 1 atmosphere, then the balloon would get bigger. If it was less than 1 atmosphere, and this is still 1 atmosphere, the balloon would get smaller. So the pressure must be equal to 1 atmosphere, so that the pressure here and the pressure here are the same. Because if this is bigger, the balloon is getting bigger. If it's smaller, the balloon's getting smaller. So it has to be the same as the pressure of the air in the room.
yeah, I mean the P squared.
P squared? No. That's not P squared. That is me saying 2 and 4 make 2. And 3 and 3 cancel.
Did you get the final answer? Say the final answer.
My final answer is 13682
1432.
1368.
Here, go on.
Show me your.
Wait, no. Look at me. No, look at me. 3 over 2 times P, yes, times V.
Wait,
What do you say?
10,
10.
10, yeah, power 3.
Ooh.
No.
Times 5.
10 to
I forgot my pi?
Yes.
Oh yes, thank you.
Wait, and can I see
This? Maybe your calculator's broken.
what happens if I not use variant?
Nothing.
No, like in calculator.
Doesn't matter.
Isn't it the same?
Yeah, it has to be. Why isn't it the same? Maybe there's something wrong with the person using the calculator.
It's Q, I tried this twice.
Oh, Fuang, that is terrible. Terrible. Right, let's look at number 6 now.
So it also has to be the V has to be 0.040.
Okay.
In there is 0.15.
No.
That's the
4.15
is the radius.
3 divided by 2. Or 0.2.
Fuang, I'm continuing now.
Wait,
No, I'm not waiting.
wait. I have answer.
Shay. Right, continuing. 6. Andrew, you got 6 there? Can you read it out?
the gas in a cylinder with radius 3 centimeters and length 10 centimeters is under a pressure of 3 atmospheres. Mechanical arm pushes down the cylinder and thus reduces its length to 5 centimeters while increasing the pressure to 7 atmospheres. How much work was done by the arm and what was the force exerted by the arm?
It increased to 7 atmospheres. Okay, so let's calculate the energy in the gas at the beginning. The energy in the beginning is 3 over 2 PV. What is the pressure in the beginning?
3 times 1.
3 times 101.35 times 1,000. And the volume? Pi or squared H. So, can you tell me this, please? And then at the end, the only difference, well, there's two differences. The pressure is now 7, is that 7 atmospheres, is it? That's 1,000, of course. But the length is now 5. And that would be a number.
14.
Yeah?
Uh,
14 what?
just 14.
That's it?
Joules.
No, that's
Yeah.
tiny. I mean, it could be. Are you sure though?
Yeah.
No, I don't believe you. I don't believe a word of that. 3 over 2 times 3 times 101.35 times 1,000 times pi times 0.03 squared times 0.1. 14. 128.9 joules. And in the second one, 3 over 2 times 7. Ah,
It's not 0.9.
what's not 0.9?
He didn't use pi.
Yeah, I didn't. I was being lazy. 1.5 times. It's rough. Oh my God. Right, give it to me, Wong, then to keep her happy. What is it?
1.9.
Point.
Nothing.
Because it's 1.8.
1.81.
Times 1,000 times pi. $150. And what was my first question?
How much work has work?
So the gas has increased in energy by how much? 21 joules. This energy didn't just appear from nowhere. It came from the arm. The arm did the work and gave it an extra 21 joules. So the answer is 21 joules. Okay, what's the next part here?
Force.
The force. Right.
We have the distance.
Yeah, you can say work is force by distance. So force is work over distance. And the work is 21 and the distance is 5. So the force was, what's that, about 400 is it? 420 newtons. So that was the force of the arm. Is there another part?
No.
That was it?
Can we use P equals to F over M?
P equals F over A. You know the A. Do you know the P? I don't know actually. Seems like you should be able to. Yes. Yes, you can.
But you have to find the pressure.
Yeah. Yeah, and the problem is, the problem is in the formula the pressure changes. It's not constant. So, actually that's a good question. If you listen to Yahia's question, he wants to know, can you use the formula, pressure is force over area, so force should be pressure times area. Now, do we know the area here? Well, we do. It's the circle, because you're pushing the circle. So what's the area of the circle? It's pi, which is 5 centimeters, was it?
5.
What was the radius of the circle?
3.
3, was it? Pi r squared multiplied by the pressure. But do we know the pressure? Well, we kind of do, but the problem is the pressure changes from
3.
7 to 3, or 3 to 7. So what do we use? Do we use 3 or do we use 7?
Average.
We can use the average. So the average of 3 and 7 is 5. So let's see what happens if we use 5. And we'll see if we get the same answer. No. We are way off. I'm sorry to tell you. Doesn't look like it. Although, I have a feeling it's something to do with the average here. I don't think it should be 5. We start off with 7 and we finish at 3. No.
Should be.
Maybe the difference is
Maybe use the difference. Yeah.
7 minus 3.
4.
That's why so
Huh?
If you go from 2. Nothing closer. 1. It's 1.
No. Yeah, exactly. No, I'm sorry, it doesn't look like we can use this formula. I'm afraid to tell you. You have an idea? Let's see what happens when we do use 1. No. No. Oh, now, I forgot. No, I didn't forget. No, sorry, it doesn't look like you can use this. Good try though, but it doesn't look like it works. Neither the pressure nor the difference in the pressure or the average of the pressures will work in the formula to give the same answer, unfortunately. Okay, we'll continue with the next lesson now. That was the tutorial. Yeah?
We have to